The Mobile Robotics Lab enables, accelerates, and sustains education, research, project-based learning, and outreach across all aspects of mobile robotics. The lab includes multiple QBot Platform autonomous systems, a QArm Mini manipulator designed for use with the ground robots, as well as communication, computing, and environment infrastructure to get your research and course started. The Mobile Robotics Lab empowers you to provide cohesive educational experiences with your students at scale. With comprehensive multi-language courseware, virtual twins with customizable environments, and multiple physical robots, the lab can be integrated in your existing courses seamlessly. Whether you are researching real-time end-to-end autonomy for safe navigation or multi-agent navigation and warehouse automation, the Mobile Robotics Lab gives you access to the agents through common research workflows in ROS, Python, and MATLAB Simulink. The QBot Platform's open application stack allows you to communicate with and integrate its operational workflows with a variety of other systems and applications, including but not limited to heterogeneous vehicle collaboration, smart material handling, and advanced student-centric projects. This lab contains the key features required to turn your space into a mobile robotics development hub. 4 QBot platforms and 1 QArm Mini empower you to tackle everything from undergraduate teaching labs and graduate capstone projects to outreach activities. A reconfigurable ground environment enables students to experiment with mobile robotics applications. Virtual Quanser QBot Platform expands the breadth of activities which each student could undertake. All curriculum activities are supported by virtual and hardware representations, ensuring students can explore remotely at their own pace, and then validate their work on the physical system. At the heart of the Mobile Robotics Lab is our QBot platform, a fully instrumented differential drive platform. A variety of electromechanical interfaces allow students to integrate their own devices via USB, Ethernet, or the expandable GPIO. Students can design complex robotic workflows with a comprehensive sensor array, including a RealSense D435, 6-axis IMU, and a 2D 360 degrees LiDAR, as well as position, speed, and current feedback on the drive motors. Powered by NVIDIA's Jetson Orin Nano and a full operating system, Quanser's QBot platform is capable of complex computation tasks. Users can take full advantage of multi-language development with support for ROS2, MATLAB and Simulink, Python, C++, and Isaac Sim. The QArm Mini is a manipulator that integrates 4 smart actuators with high-end encoders, current and load sensing, and speed and temperature feedback. The dual-digit gripper supports grasping objects up to 70 millimeters in size with a maximum payload of 150 grams. To enable flexible project design, the QArm Mini also supports a mobile configuration with a plug-and-play interface powered by the NVIDIA computer in the QBot platform. Visit Quanser.com if you would like more information, where you can get in touch with us or request a demo.